Okay, now we're going to be discussing the concept of exception handling and how it can be used to avoid any sort of, errors with respect runtime errors, especially. Now, if you remember what a runtime error is basically when the code is running and it gets an input that it cannot handle, and because of which the program or the code crashes. So and it could be, an example, a very common example of a runtime error is that if I attempt to run my code and it attempts to divide something by zero. So division by zero, you write a code for a calculator, and the calculator in the denominator portion, you give a zero and you actually dividing two numbers together. And the second number, the divider becomes zero, because of which the code will crash because division by zero is not possible. Now this is known as as a runtime error because my code will instantly crash. Now, if I have a runtime error, these runtime errors are known as exceptions. Now, one scenario can be that when a runtime error occurs, my code crashes and it has this ugly looking red text in front of me that's telling me that your code crashed because you had divided by zero. Now, second scenario can be that I put in place a technique of method of avoiding this thing from happening. And if, say, for example, a runtime error does in fact occur, then my program actually handles that in a very graceful manner. In fact, it presents an alternate execution path of my choice. So it's sort of like an if condition, but it strictly deals with runtime errors. And dealing with these runtime errors is known as exception handling because runtime errors are exceptions. Runtime errors can occur for many reasons. Some examples are division by zero, invalid array indexing, another very common example. That's why, if you remember, when we studied bubble sort, when we're comparing two elements together in an array, and we have n number of elements, we stop the loop of comparison at n minus one, because if I have, say, for example, 7 elements in an array, I compare one with the second, second with the third, third with the fourth, fourth with the fifth, fifth with the sixth, sixth with the seventh, and I stop at seventh because there is no eighth. There is no eighth, so I cannot compare seven with the eighth element. So if I do attempt to do that, this will be considered as a runtime error because I accessed, I was indexing a position that does not exist in my array. So that is another example of a runtime error. Similarly, if you're talking about file handling, may it be binary file, there's a there will be a whole lecture on how binary files are used and how they are accessed. We studied file handling with respect to text files in paper 2, but with respect to binary files, there's a whole different set of techniques in Python that is known as pickling. We'll be looking into that later. Now, with respect to that, if, say, for example, in your file handling code, you write a file name that doesn't exist, and when that code runs, it will try to access a file that does not exist, because of which a runtime error will occur. So these are possible scenarios where runtime errors occur, and to handle these runtime errors, if you don't handle them, the code will simply crash. Now, they can handle by, which is resolved by an error subroutine known as exception handler, rather than letting the program crash. So usually the outcome of runtime error is the program crashes, but we can avoid that. Any runtime error that occurs during the execution of statements A, say for example, this is the pseudocode syntax of runtime errors. I write it under the try heading. So at the try body, these are the statements that are supposed to run under my normal circumstances. It could be anything. My normal program, which I hope that a runtime error does not occur in, but let's just say this is my normal program that I'm running, and let's just say that during my normal program, a runtime error does in fact occur. Now, if a runtime error occurs in the normal execution of these statements, my immediately control will be shifted towards the except block. And that basically means that exception has occurred. And instead of going to an error screen, a default error screen that might not mean much to a lot of people, but instead of going to a default error stream, I will go to this set of statements which are put in place to run whenever an exception occurs. So that means if the code crashes, instead of presenting an error screen, I will present these statements here. And I can choose what to write here. I write the statements here. So runtime error that occurs in the execution of statement A is caught by the handled by executing statements B. VB.NET and Delphi are designed to treat exceptions as abnormal and unpredictable erroneous situations. Python is on the other is designed to use exception handling as flow control structure. So basically, they're treated as an else statement sort of, and basically my execution is shifted from the basic code, the try code, towards the exception code. So whenever there is an exception, I can shift my control of execution towards the except block. Now, this is an example of how Python implements an exception. So I've created a subroutine exception. I'll take an input first, a second input, or both of integer types. My try block is simply going to divide the first and second number. Now, let's just say that second number, as you can see here during execution, the second number was input as 0. And what I'm doing here is I'm dividing the first number by the second number. So 5 divided by 0 is not possible. Division by 0 is not possible. So under normal circumstances, this code will crash here and a red text will be presented in front of you. But not here. What's happening is that since this code has entered an exception, because of that second being 0, my Python will shift the control towards the except block. And as you can see here, this line will be printed. So this is how I'm handling any sort of exception. I could write any message I want here. In fact, I can choose to write multiple statements here that are put in place to handle if an exception occurs. So if you can see here, first number enters 5, the second number is entered 0, and we'll simply write division is not possible. And however, if I use second number as 3, in this second example, input first number 5, second number is 3, and the result is printed as it's supposed to be because this code did not crash, and I stayed in my try block, and the result is presented as calculated in the try block. But if the code crashed for some reason, only then the control will be shifted to the except block. Now, Python distinguishes between different types of exception. It could be IO error, for example, file cannot be opened. The name is wrong, it doesn't exist. Import error, Python cannot find a module that I'm trying to use in my code. Value error, an argument has an appropriate value. So for example, I'm asking a parameter to be of a certain type, but the value that I input is of a different type. So that will cause an exception. Keyboard interrupt, the user presses Control C or Control delete. End of file error, a file read meets an end of file condition. This technique is very heavily used whenever we're dealing with binary files. So for example, binary files treat, basically if you look at we'll be looking into this in a bit, but binary files are, unlike text files, binary files hold records in them. So if I want to read all of the records, I want to read it till I reach the end of the file. So if I try to read some record that's the end of the file, and that's actually, I try to read something that's after the last record, that might cause an exception. So I have to deal with that in using exception handling. And most importantly, last but not least, zero division error is another type of exception that can occur in Python. So this is a technique, just a simple technique that should be employed whenever you're using programming code. And to avoid any runtime errors, this is the best approach to do it.